forward. And so today, y'all, we are going to go over section 3.5. Make sure my mic is on. The mic is on. Good. So let's see. This here, y'all, is 3.5. So this is the last section of chapter 3. And in 3.5, y'all, we're talking about division of whole numbers. So it says division models. It says in the grade 3 Common Core standards, we find that students should be able to interpret whole number quotients of whole number quotients of whole numbers. For example, to interpret 56 divided by 8 as the number of objects in each share when 56 objects are partitioned equally into 8 shares. Okay, or as the number of shares when 56 objects are partitioned to equal shares of 8 objects each. Okay, so y'all, when I talk about like back in the day when we used to teach like maybe like a little bit more basic of a remedial math course, and I used to try to tell my students the difference between, because sometimes people didn't know, what's the difference between 12 divided by 4 and 4 divided by 12, okay? So the easiest way I used to teach this, and I think this actually makes a lot of sense when you're trying to show this to elementary school kids, is suppose that the number on top talks about, say, candy bars, and the number on the bottom is people. So if I have 12 candy bars and there's 4 of us, how many candy bars would each of us get? Anyone know? 3, right? So we'd have 3 candy bars per person, right? Now, if I do it this way, that means that there's 4 candy bars, right? But there's now 12 people. And if I were to sort of reduce this fraction, and I know in elementary school we talk about fractions, we haven't talked about it yet, but we know what fractions are. And I were to reduce that, that would tell me that there's 1 candy bar for every 3 people, right? And that's a much different scenario. So 3 candy bars per person, right? Halloween's coming up. You'd much rather, if you're out, you know, little kids are out there trick-or-treating or whatever, I'm sure they would much rather get 3 candy bars themselves than have to share 1 candy bar with, say, their 2 siblings or something, right? Like we got 1 candy bar, but you got to share with your brother and sister. And not the same kind of thing, right? So anyway, that's what we're talking about when we're talking about division, right? We're talking about sharing, okay? So it says the definition of division of whole numbers, the missing factor model. So it says for any whole numbers A and B, where B is not divided by 0, A divided by B is equal to C if and only if C is the unique whole number such that B times C equals A. Okay, so we don't necessarily think about that a whole lot when we do division because we've learned how to divide when we were in elementary school, and when we have to divide stuff out, we just kind of, you know, do it like second nature. But the problems here say to rewrite each of the following division problems as a multiplication problem. Okay, so let's go ahead and do that. So if I wanted to rewrite 49 divided by 7 is equal to 7 as a multiplication problem, everyone agree we could say 49 equals 7 times 7, right? That's what that part means. And if I were to do the same thing here, wouldn't I say 350 is equal to 5 times x, right? Okay, and so for the next problem I have here, it says for each of the following, find whole numbers to make the statement true if possible. Okay, first question. Again, 48 divided by 6. So y'all, I told y'all in our Blackboard page, let me come back over here real quick. On our Blackboard page at the very top, I did include a multiplication table, okay? So I'm just gonna kind of zoom in on this here because when I'm doing these problems, it's gonna help me out, right? Like 48 divided by 6, and I know we all know how to divide, but 48 divided by, was it 6? Yeah, 48 divided by 6. So I'm gonna scroll here to the 6 and I'm gonna look for 48, here it is. And so 6 goes into 48, how many times? 8 times, right? And again, when you're teaching this to kids, the multiplication table comes in really, really handy, right? So right here, y'all, I'm gonna put an 8. Let's see. Does anybody know what number do I have to divide by 62 to get 0? 0, right? Okay. And then one more, 20 divided by what's going to give me 5? 4, right? Okay. So again, and like I said, y'all, the division problems here are pretty simple, right? But again, when you're teaching this to children, the multiplication table comes in really, really handy. And I'm going to be 49 pretty soon, y'all. But what I want to say is, I'm pretty sure that your experience in elementary school is probably similar to mine in that you guys use the multiplication table, right? I don't really think that's changed a whole lot. Maybe it has, but that's how we kind of did it. Okay, so let's take a look at the next one here. It says, if 20 divided by A is equal to B, then let's find 20 divided by B. Okay, so y'all, in doing this problem here, what I would probably do is I would say, look, let me pick a number for A. And since I'm dividing 20, I want to pick a number that I know I can divide into 20. So a number that I can divide into 20, I don't know, maybe 4, right? So let me put a 4 right here. Come on, pen. Let me put a 4 right here. And so 20 divided by 4, everybody agree that would be 5? Okay, so that's telling me that my number B is going to be equal to 5. Okay, so then now I can say, look, let's take 20 and let's divide it by B, which is 5, and that would have to be equal to 4, right? So if I know how to do this with these numbers right here, and if this number 4 was really the number A, then 20 divided by B would just be whatever the number A is, right? And that's all it's kind of telling me there, okay? All right. So now we have something called the fact family for 63 divided by 7 is equal to 9. Okay, so look, y'all, if we're going to write the complete fact family for 63 divided by 7 equals 9, the first thing I want y'all to notice is it says identify all 4 facts. So I know there's going to be 4 answers here. So again, if I'm thinking about this, 63 divided by 7 is equal to 9. I want to look for what other little equations that I have through my A through L. There's a bunch of choices here, right? It looks like there's 12 choices, and I'm only going to pick 4. Represent this same expression, okay? So let's take a look. If I look at the first, say 4 right here, or this first column, which of those would you say is equivalent to this piece right here? Are any of them going to be equivalent? What do y'all think? So let's go through one. Is 9 divided by 7 63? No, okay. And 9 divided by 63, remember we need to do it the other way, right? So wouldn't we need to pick 63 divided by 9? Okay, so let's pick that one there. And we know 7 divided by 9 is not 63, so I'm going to pick that one. Okay, now let's look at the next chunk here. 9 times 63 is 7? No. 7 times 6? No. It doesn't look like I'm going to pick any of those over there, right? Okay. So remember, I'm looking for a total of 4 answers. What about this one? 9 times 7 is 63. What about 63 divided by 7 is 9? And what about 7 times 9 is 63, right? So I found my 4 choices, right? And that's all I'm really looking for here, okay? Okay, so the next thing we have here, y'all, is something called the division algorithm. And it says, given any whole numbers A and B where B is not 0, it says there exist unique whole numbers Q, which is our quotient, and R, which is our remainder, so that A is equal to B times Q plus R. Okay, so all we're going to do here, y'all, is like we're going to pretend we're back in 4th or 5th grade, and we're going to do some division, okay? So look, I have 18 going into 425. So again, y'all, remember, I know you all know how to do this division, but what I want to think about is how do we, the process and how we teach children, right? So the first one we say is, look, does 18 go into 4? No, it doesn't. So sometimes they might have put a 0 right there, but then they might say, okay, look, does 18 go into 42? And again, when you're teaching this to kids, what you're looking for is what's the closest number to in 18 that's closest to 42 without going over. So what I want to do is I want to show you on my multiplication chart. Okay. So look, here is 18 right over here. Let me zoom in right here. Okay. So here's my 18. I'm looking for the first number closest to 42 without going over 42. You guys agree 36? Right? Okay. So this is again what we would do. We would put a 2 right here, because 18 times 2 is going to give us 36, right? And then we're going to have to borrow because we know that we can't take away 2 from 6. So we're going to say, look, that's a 3, carry my 1. I know it's a little messy there. But 12 minus 6 is going to give me 6. And then I'm going to bring down my 5, right? Okay. And then, y'all, I'm going to play the same game again. I'm going to say, look, what's the next number closest to 65 on 18 without going over 65, right? So here's 18. The closest number to 65 without going over it is 54. And we have to multiply 18 by 3, right? So we're going to come back over here and we're going to say, look, that's a 3. And that gives us a 54. Okay. And we're going to subtract again, and that's a 1, and that's a 1. Okay, so how many times did it actually go in? It went in what? 23 times? And what did we call this guy down here? That was our remainder, right? That was our remainder of 11. Okay. But again, this was the process. And so again, I don't know about you guys, if you remember that. I don't remember using the table all that much, but I think it's a really helpful tool because it shows you, and you can see it visually, okay, how many times do I need to do this? And I don't know about y'all, but I remember as a kid, like it just felt like I was guessing. Let me try 5. Okay, that's not enough. Let me try 9. Okay, that's way too much. And let me try 6, right? And it was just like a lot of guessing. And like, I don't want to have to guess 100 times, obviously I'm exaggerating, but I don't want to have to guess a ton of times. I'd rather be able to find my answer much quicker. And I think the other advantage, is I don't know how you guys are with, I know a lot of people struggle with math and stuff. I mean, I struggle with it too. I failed it 7th, 8th, 9th, and 10th grade. I really did. But for people who don't remember these multiplication facts, the more often that you use your table, the more you're going to remember it because you keep looking at it over and over and over again, All right, let's try another one. So here we go. 21 into 518. Okay, so again, I know that 21 won't go into 5, but I want to know how many times might it go into 51, right? And again, y'all, if I were to look at my table here, I know I don't have a 21, but I have a 20. So I know if that's 20, the next one would be 21. If that's 40, it's got to be 42. This would be 63, so on and so forth, right? So I might say, look, this might go in twice, which gives me 42. Okay, I'm going to borrow 1 from there. So now I have 11 minus 2 is 9, and bring down the 8. And then I might say, okay, well, 21 into 98 would probably go in about 8 times. Not 8 times, I'm sorry. 4 times. Because that's going to give me 84? Okay. And then we can subtract again, and that's going to give me a 4 and a 1. So it looks like this went in 24 times with a remainder of 14, right? Okay. And y'all, so for the third one, I'm just going to kind of do it over here because I did kind of run out of room there. Okay. So again, I know that 99 won't go into 1. I know it won't go into 10, but it will go into 102 probably 1 time. Okay. And so, again, I can't take away 2 from 9. So look, I don't know if y'all ever, if your teachers ever did this with you guys, but they might say, look, instead of borrowing from the 0 or borrowing from the 1, think of that as a 10, borrow 1 from it. It's now a 9, right? So 12 minus 9 is 3, and 9 minus 9 is 0, so I don't need to worry about that. And then bring down my 2, okay? And then does 99 go into 32? No, right? So we got to put a 0 right here. And so my remainder is 32. So right here, y'all, I'll have a 10 with a remainder of 32. And if y'all remember, y'all, that when we did this and back in elementary school, the idea is that my remainder should always be smaller than our divisor, right? So the remainder should always be smaller than whatever we're dividing by, right? So 11 should be smaller than 18, okay? But again, and again, like I said, y'all, can you do this by yourself? I know y'all know how to do this by yourself. I think the approach is use a multiplication table when you're teaching this to kids, okay? Okay, so for the next couple of problems, y'all, it says, show that in general, each of the following is false if A and B are whole numbers. And it says A divided by B, then divided by C, is the same thing as A divided by, and then B divided by C. So, y'all, this is not true. Again, just a reminder, when we regroup the parentheses, that refers to the associative property. The associative property and the commutative properties, y'all, work for adding and multiplying, but they don't work for subtracting and they don't work for dividing. And the same thing when it comes to the distributive property. The distributive property does not work with division, okay? It doesn't work with division. Okay, so let's take a look at the next one here, and it says, using a calculator, it says Sally multiplied by 10 when she should have divided by 10. And it says the display ran 700. What should the correct display be? Okay, so let's think about this for a minute. She was supposed to divide by 10, but she ended up multiplying. So when she took her number, whatever it was, times 10, that gave her 700. So we want to know, well, what number did she have on our calculator? Well, if we were to divide both sides by 10, then that would have meant that her number would have been 70, right? Because 700 divided by 10 would give me 70, okay? But she was really supposed to take this number and divide it by 10. So if I take 70 and I divide it by 10, what number would we get? Yeah. And that's all we're doing there, okay? Okay. So, y'all, for the next problem that I have right here, it says use base 10 blocks to illustrate 131 divided by 5. So again, I'm going to go back to like the way we did this a little while ago, right? So a little while ago, we said, look, let's take the number 131 and let's divide it by 5, okay? So y'all, in the number 131, remember, flats are like how many hundreds I have, right? Longs are how many tens I have, and the units are how many ones I have. So how many hundreds do we have here? There's one of them, right? There's 100 because it's 131. So how many tens do we have? Well, we got 10 ones, right? Or 10, I'm sorry, 3 tens. And how many ones do we have? We have one of them. Okay, so the idea behind using this kind of division here is when we were going to divide this way, does 5 go into 1? What do you think? No, it doesn't, right? So what we say is there are no sets, right? But there's one left over, okay? Why one left over? Because that's the number that I have right there. Okay, now the next thing it says, look, we're going to convert the flats to longs. So when we do our division, don't we say how many times does 5 go into what? 13? Okay, so look, we're going to put a 13 right here. Okay, now how many times does 5 go into 13 anyway? 5 times 2, right? So we're going to have 2. Okay, look, we're just going to do our division. When we subtract, how many are left over? So there's 3 left over, right? Okay. Now it says converting the remaining longs to units. So we know 5 doesn't go into 3, but we bring down the 1. So we have a total of 31 units, okay? Now how many times does 5 go into 31? 6 times. 6 times here, okay? So that's going to give me 30 with a remainder of 1, right? Okay. So therefore, the quotient is going to be what? Or what's our answer? It's going to be 26 with a remainder of 1. And that's all that they're really kind of showing us there, right? right, I'm going to keep moving along here. Okay, y'all, for this problem here, I'm going to come back. I'm going to do this problem at the end, okay? And not that it's difficult, but it's going to be a little bit more time consuming. So look, we'll come back to this problem at the end of the section of 3.5, and we'll go through each of them, okay? So look, let me keep scrolling here. And let's take a look at the next part. So it says students were divided into 10 teams with 12 on each team. Later, the same day, students were divided into teams of 6 on each team. How many teams were there then? Okay, so first thing I want to figure out is if we had 10 teams with 12 on each team, we could find the number of students by multiplying those out, and that would tell me that there are 120 students, right? Now, we're going to divide those 120 students with 6 on each team. So if we divide it by 6 students, right, because we're going to get groups of 6, 6 goes into 120, what, 20 times? So there's 20 teams of 6 students each. All right, so for the next problem I have here, y'all, it says Dave purchased a $21,000 life insurance policy at the price of $24 per $1,000 of coverage. If he pays the premium quarterly, how much is each statement or installment? I'm sorry. Okay, so let's figure this thing out. All right, we have a $21,000 life insurance policy, and they charge me $24 for every $1,000 worth of coverage. So what I want to do is I want to figure out how many groups of 24 do I have, okay? So look, y'all, let's take 21,000 and let's divide it by 1,000 because they charge me for every 1,000. So when we do that, that should give me the number 21, okay? So I'm going to have 21 groups, right? Because they charge me for every 1,000. Now notice how much they charge for every 1,000. They charge me $24, okay? So look, I'm going to grab my calculator here. Oops. And I'm going to say, what's 21 times 24? And that's giving me the number 504. Okay. So my total bill is going to be $504. But now the question says, if we pay the premium quarterly, when we pay it quarterly, y'all, it means we're going to pay it in 4 chunks. So now I'm going to take that number 504 and I'm going to divide it by 4. And I'm coming up with 126, right? So each installment should be $126. Okay. All right. Again, y'all, like I said before, that this class really prepares you, or once you graduate, you can teach anywhere between K through 8. And usually about 7th or 8th grade is when they start talking about order of operations. So if you think about order of operations, and a lot of us when we were in junior high probably learned this. Anybody learn PEMDAS or please excuse my dear Aunt Sally, right? Okay, so remember what the P stands for. It says, hey, do all the stuff inside our parentheses. Oh my goodness. I just changed the battery last night too. There we go. Change them, perform all operations in parentheses or brackets or whatever, right? And then remember the E says stand or evaluate any kind of expressions. Now, y'all, the M and the D is multiply and divide, but I want you to notice what it says. It says multiply or divide in order as we go from the left to the right. So I told y'all I failed math 7th, 8th, 9th, and 10th grade, and I know that in junior high, I struggled a lot with order of operations because when I learned PEMDAS, it says M and then it says D. And so in my mind, I said, I have to multiply and then I have to divide. But the real order of operations says, do it whichever one comes first. And I probably missed that as a kid, because when you're in 7th grade, you miss a lot of stuff, right? So I got to make sure that I do it in order from left to right. Same thing with adding or subtracting. I got to make sure that I do that in order from left to right, okay? So thinking about my order of operations, okay, the directions here say place parentheses if needed to make each of the following statements true, okay? So I want you to notice what I have here. We have 4 plus 3 times 4 equals 28. So y'all, just to give you an example, if I did not put any parentheses here, what would I do first? Would I do 4 plus 3? Would I do 3 times 4? What do you think I would do first? We would do 3 times 4. That would give us 12, and that's supposed to be equal to 28, but we know, yeah, that's not true. In order for us to get 28, don't we need to group my 4 and my 3 together? Because if I put my parentheses here, 4 plus 3 would give me 7, and then 7 times 4 would give me 28, I'm sorry. So it looks like my choice here would be A, right? I would need to do that one right there. Okay. I'm going to move on to the next one. And it says 12 divided by 4 plus 4 equals 1. Okay. So again, I want to know, do I need to put parentheses or do I not need to put parentheses at all? And so again, y'all, I'm going to look at this problem here. And I think if I think about my order of operations, right? Parentheses, exponent, multiply, divide, add, subtract. Okay. So I don't have any parentheses. I don't have any exponents. Multiply and divide. If I were to divide first, 12 divided by 4 would give me 3. 3 plus 1 would give me 4. So we don't need any parentheses at all, right? Now, I want to point something out here, y'all. If you did this one here, it would say do the parentheses first. And 12 divided by 4 would give me 3. And 3 plus 1 would give me 4. And it's not that that's incorrect. It's that we don't really need to put them there because we were already going to do that. And that's why I would choose D, okay? All right. So again, if I look at the next one here, it says choose the correct answer below. 5 plus 4 plus 9 divided by 2 equals 9. So again, y'all, if I didn't do any parentheses, the first thing I would have to do is take 9 and divide it by 2, but that's not going to go in nice and neat. So I know that I'm going to need some parentheses here. Let's see. If I were just to go left to right without the division, 5 plus 4 is 9, plus another 9 is 18. And if I took 18 and divided by 2, that would give me 9. So I need to group the first 3 numbers. So that would be A, okay? And then again, if I look at the next one here, it says 5 plus 6 divided by 2 plus 4 equals 12. So again, I'm going to try doing this without any parentheses. 5 plus 6 divided by 2 is 3, plus 4, is that equal to 12? Well, 5 plus 3 is 8, 8 plus 4 is 12. Yeah, we don't need any parentheses there. Just going through the order of operations, everything would be good. Okay. Okay, so now for the next problem, it says, what computation should be done last in 4 parentheses 16 minus 9 minus 18? Okay, anybody know what would be the last thing we would do? Subtract what? 18, right? Because the first thing we would do is we would say, look, what's 16 minus 9? Oh, that's 7, right? And then we would say, look, what's 4 times 7? That's 28. And so the last thing we would do is we'd subtract 18, right? Okay. All right, now look at the next one here. It says, what computation should be done last in 54 divided by all those parentheses? So again, y'all, if you can think about it like this, look, let's do what's inside the parentheses. What's 10 minus 4 anyway? Anyone know? 10 minus 4? 6, right? What's 6 plus 9? 15. So what's the last thing we're going to do? We're going to divide 54 by 15, right? Okay, good. All right. And so the next one, again, I'm just kind of going through the motions here, right? If I'm doing my parentheses first, 14 minus 4 is 10, plus 4 times 9 is 36. So the last thing we would do is we would add 10 and 36, right? Okay. And let's see. The next one says, what computation should be done last in 720 divided by 180 plus 8? So I know I'd have to do my division first. So whatever 720 divided by 180 is, 4. And then we're going to add 8. So the last thing we're going to do is add 8, right? Okay. Okay. So look, y'all, let's come back up here and let's finish off these other problems that I hadn't done yet. Okay. And so what I want to do here, it says, perform each of the operations using the bases shown. Okay. So y'all, again, a lot of times when we're dealing with different bases, it kind of gets a little confusing, or it can be confusing. So I really want to take my time with these problems. What I'm going to do first, y'all, I'm going to do the ones where I have to multiply first. And then I'll come back and we'll do the division problems, okay? So look, let's do part A. It says 32 base 5 times 3 base 5, okay? So I'm going to write my problem like this, just like the way we did when we were in elementary school. We write the bigger number on top, the smaller number on the bottom, okay? Now, I want you to think of, we're in base 5. That means that we're regrouping when we have fives or numbers 5 or more, okay? So let's take a look here. First question, what's 3 times 2? 6. But in base 5, doesn't that mean that there's 1 5 and 1 1? Because a 5 and a 1 would give me 6. So there's 1 5 and there's 1 1 in base 5, okay? Now, 3 times 3 is going to give me 9. But I'm thinking about base 5. In base 5, 9 would mean that there's 1 5 and 4 1s. Does that make sense? So I'm going to put my 4 1s right here and my 1 5 right there, okay? Now, what I'm going to do now, y'all, I'm going to just add straight down. So here's my 1. Now look, 1 and 4 gives me 5. But in base 5, that means that there's no 1s and there's 1 5, okay? And so now 1 and 1 is going to give me 2. So my answer is 201 base 5, okay? That's how I'm thinking about my numbers in base 5, right? I'm regrouping after every 5. Okay. Now look, let's do part C. We're going to do part C the same way, okay? This is 35 base 6 times 21 base 6, okay? And I'm multiplying. Now I'm in base 6, so I'm regrouping after 6 or more, okay? So look, let's go slowly here. 1 times 5 is still 5. 1 times 3 is still 3. Okay. Now, let's think about the 2 now. 2 times 5. 2 times 5 is 10. But if I'm in base 6, that means that there's 1 6 and how many 1s? Anybody know? Think about the number 10. If you subtract away 6 from 10, how many 1s are you left with? 4, right? So there's 4 1s and there's 1 6. Okay. Now, let's do the same thing again. 2 times 3 is 6, and 1 more gives me 7. But if I'm in base 6, that means that there is 1 1 and 1 6, doesn't it? Am I making any sense here, y'all? Are we okay? No? Yes? Yeah, we're okay? All right, let's go. We're going to go slowly here. We're going to add. Look, here's 5. What does 3 plus 4 give me? 7. But I'm in base 6. That means that there's a 1 and there's another 6. Okay? So 1 and 1, it gives me 2, and bring that 1 right there. And so my answer is 1 2 1 5 base 6. Okay. All right, let's do part F. Okay? So look, I'm going to write 1 0 1 1 0. I'm in base 2 times 1 0 0 base 2. Okay? All right, so let's think about this again for a minute. I'm in base 2. That means I'm going to regroup when I have 2 or more. Okay, so let's go ahead and multiply. Well, 0 times 1, 2, 3, 4, 5, that's still 1, 2, 3, 4, 5 zeros, okay? Now this 0 times 1, 2, 3, 4, 5 is still 5 zeros, okay? Now we're going to multiply. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1 again. 1 times 0 is 0, and 1 times 1 is 1. Now I'm just going to add straight down. I got a 0 here, a 0 here, a 0 here, a 1, a 1, a 0, and a 1. And here's my answer in base 2. Okay. Okay, so y'all, look, we did the multiplying ones. Let's come back, let's do the division problems. So I want to think about this number. This is 32 base 5 divided by 3 base 5. Okay, this is part B. 32 base 5 divided by, what was it, 3? Yeah, divided by 3 base 5. Okay, so I'm going to do my division just like the way we've done before. Okay. Is that a 3? Yeah, it's a 3. Okay, so y'all, when I'm dividing, again, it makes it a little bit challenging, right? Because I'm not in base 10 anymore, I'm in base 5. So one thing I might say is, look, how about if I multiply it by 10? What's 3 times 10? 30. So I'm going to put a 30 right here, okay? Okay, now we're going to subtract, and when we subtract, I have a 2 right here, and that's not going to go in anymore, okay, because the 3's minus 3's gives me a 0, so those cancel. And 3 won't go into 2, so my answer here, y'all, is going to be 10 base 5, remainder 2 base 5, okay? I'm going to do the same thing for the next one, okay? Where are we? Here we go. 233 base 5 divided by 4 base 5. Okay, so 233, oops. 233 base 5 divided by 4 base 5, okay? All right, so when I'm trying to divide this here again, y'all, I'm going to play the same kind of a game. I'm going to say, look, let me multiply this by 10. So I know 4 times 10 is going to give me 40, right? Okay, so I want to see what's going to happen here. So when I subtract, 3 minus 0 is going to give me a 3. Now, does everybody agree that I can't take away 4 from 3? So I got to borrow 1 from that. There's a 1 right here. Now, remember, y'all, I'm borrowing, but since I'm in base 5, it's not really borrowing a 1, it's borrowing a 5. So 5 and 3 would actually give me an 8. So 8 minus 4 is going to give me a 4, and then I'm going to carry down my 1 again, okay? Now, I'm going to play this game again. I'm going to say, look, let me try multiplying that by 10, okay? So I know 4 times 10 is going to give me 40, okay? So I'm going to subtract again. That's going to give me a 3. That's going to give me a 0. That's going to give me a 1, okay? I'm going to try that again. I'm going to try a 10 again, okay? So look, y'all, when I try a 10 again, that's still going to give me a 40. Now again, I'm going to subtract here, y'all. So 3 minus 0 is 3. Now I can't take away 4 from 0. So when I borrow 1 from there, remember, I'm borrowing 1, but because I'm in base 5, that's really a 5 that I'm borrowing, right? 5 minus 1, I'm sorry, 5 minus 4 is 1. Okay. And I'm left with a 13. Okay. Now I might try, say, 2. And let's see, 4 times 2 gives me how much? 8. Okay, so 4 times 2 gives me 8. But how do I write the number 8 in base 5? Doesn't that mean that there's 3 1s and 1 5? Isn't that really the number 13? Does that make sense on how I'm doing this? Okay, so my remainder is 0. Okay, so now what I'm going to do, y'all, I'm just going to add up my numbers here. 10 and 10 and 10 is 30. And then the 2, oops, I forgot to add the 2. So this becomes 32 base 5 and no remainders because it went in nice and pretty. It's a little different, isn't it, when we're doing the division with different bases, the same thing with the multiplying, because we're so accustomed to dealing with base 10, it's a little bit different when we deal it with different bases, okay? And I want to say there's one more, y'all. So let's come back over here. Here it is. Okay, so 11, 0, 11, and divided by another 11. Okay, so let me do it over here where I have some room, port E, 11, 0, and 11 in base 2, and we're dividing by that an 11 in base 2, okay? So let's see what we can do here. We can probably just go through like standard division. 11 goes in 11 how many times? Once, okay. We're going to subtract. Okay, now here's the 0, and that's the next one we have. Can we divide 11 into 0? No, so we're going to put a 0 here. Then we're going to bring down the 1. Okay, does 11 go into 1? No, so we're going to bring that down. And then we're going to put another 11, and 11 goes in 11 one time, and no remainders. So my answer would be 1001 in base 2. Okay, and that's how I do my problems. So again, y'all, just to give you a heads up, when you're working, you do have a question like this in your homework, and when you're working through this problem, think about what base you're in, right? So when you say, okay, 4 times 3 is 12, but if you're in base 5, 12 really means you have 2 5s and 2 1s, right? So you want to think about them that way, okay? All right, anywho, y'all, that is 3.5. So let me go ahead and stop recording here. Come back over here. Let's stop on the record.